Hi everyone. In today's challenge, we are going to solve this problem Stone Game 3 and the problem number is 1406. Alright guys, so first of all what we are going to do, we are going to clearly understand what this problem say. After that we are going to move to the logic part, we are going to see how we can solve this problem. And after that we are going to move to the implementation part, we are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem say, right? So let's understand this problem statement first. So problem statement says Alice and Bob continue their game with a pile of stones. Alright. There are several stones arranged in a row and each stone has associated value which is an integer given in the array stone value. So guys, we are given an array. The name of the array is going to be nothing but value. Alright. And in that array, let's say if there are some values like this, that means this is nothing but a stones. On 0 index we have 1 stone. On second index we have 2 stone. On third index we have 3 stone. On fourth index we have 7 stone. Alright, so now it says Alice and Bob take turns with Alice starting first. So who gonna play first? First turn is gonna be for Alice, right? On each player turn, that player can take either one, two, or three stone from the first remaining stone in the room. Now this is the logic main, or we can say trick of this particular problem. So if Alice gonna start first, or anyone who gonna start first, or who has a turn, he or she can take either first, we can say first stone pile, or at a time two pile, or at a time three pile, right? So he or she has a choice. Either he can take one pile or two pile or three time at a time, right? Now we can say the score of each player is the sum of the value of stone taken. The score of each player is 0 initially. Now the score is nothing but let's say Alice took a first pile, right? She took only one first pile, so the score is going to be now 1 for Alice. If she took two pile at a time, so score is going to be nothing but the sum of these two. This is nothing but 3. If she took at a time 3 piles, so the score is going to be nothing but 3 to 5 plus 1 is nothing but 6, right? So this is going to be the score for Alice. And initially score for everyone means Alice and Bob is going to be nothing but 0. And we can say this is the thing, and who will gonna win the game, who will have a maximum score, right? The objective of the game is to end with the highest score, and the winner is the player with the highest score, and there could be a tie. So there may be the case that Alice also has, let me not have Alice also have a 4 stone and Bob also have 4 stone, right? So this could be the, we can say the tie game, right? So we don't gonna return any of the winner, we will return tie, right? Assuming Alice and Bob play optimally, right? And return the allies if allies win, Bob if Bob win, and or tie if they will end the game with the same score. So same thing we have already seen. If allies is gonna have a more stone, we are gonna say allies is gonna win the game. If Bob is gonna have a more stone than allies, then we're gonna say Bob is gonna win the game. If both have a same number of stones, so we're gonna say no one is gonna win, it is a tie, right? So there's some keyword, right? Tie, Bob, and allies we have to return in the case of this scenario. So this was the problem statement. I hope you understood this. Let's understand this with example one. So we have this array, right? Values array 1, 2, 3, 7. This zero index we have one pile, one stone. At second pile we have we can say two stone. Third pile we have three stone, and fourth pile we have seven stone. Fine. Now what we have to do? We have to check who is gonna win this game, and see both are playing optimally, right? Assuming Alice and Bob play optimally. So how we can check it? But for this problem statement, let me tell you how this gonna work. But this is not a logic part, right? We will see the logic part after this. So this time Alice is gonna take all these one, and Alice will have now stone six, we can say six, right? Next time Bob will gonna take one only because there is no more stone. But still, even taking one stone, Bob is gonna have seven stone. So we can say Bob is gonna win the game no matter in any case, because if Alice start with one as well, so Bob is also gonna take all the stone, right? Because Bob has a choice to take at least one or at max three, we can say what is this piles at a time, right? So Bob is going to take all the piles. That case also Alice is going to have only one stone. Bob is going to have 3 to 5 and 7 to 11. There also Bob is winning. If Alice take two stone at a time, then Alice is going to have a 3 stone, and the Bob is going to take all rest of the pile. This is nothing but 10. So here also Bob is getting win. So in no matter in any case, Alice is always losing the game and Bob is always winning the game, right? So we are going to return Bob. I hope it makes sense, right? Now, this is the basically the problem statement you have to understood first. Now let's move to the logic part and see how we can solve this problem. And see guys, logic is going to be really easy for this problem, right? Even though it's look hard, but it's not actually a hard problem. It's a very, we can say medium level problem. How we can solve this problem? See, we have to just don't consider this, we can say this particular statement or this particular statement. We have to check who is winner, right? We have to just consider one thing, that either you can make a Bob to win or you can make a light to win. allies to win, right? So I'm assuming that I want to see whether allies will win or not, right? For me the problem statement is like I want to see whether allies could win or not. If allies is not winning, then I'm going to return bow. If allies is winning, then I'm going to return allies. If allies is having the same number of we can say stone as bow, so I'm going to return tie. So how could I see that particular part? For that, guys, I'm just going to say find out the difference allies and bow. Number of stone allies has taken, number of stone bow has taken. If the difference is greater than 0, that means we could say allies has more stone, right? Then also we can say difference is going to be greater than 0. If it is greater than 0, then what you can do, you can return allies. But if it is less than 0, that means both have more stone than allies, so we have to return both. But if it is equal to 0, that means both have same stone, right? So we are going to return tie. Now how we can find allies minus bow, right? How we can find this particular thing? So for this, there is a simple, we can say a recursion, and how this recursion is going to work, let's see, right? So what I'm going to do, I'm going to let us scroll this and let's take a first example. So this is nothing but 1, 2, 3 and 7, right? We have this number of piles, 4 piles with a given each piles have 1, 2 and 3 and 7 stone, right? Now what we're going to start with a function from 0, right? And you know that this turn is always going to be for allies, right? Fine. So from 0, allies can take only one stone, like not one, allies can take only one pile, and allies can take two pile at a time, and allies can take three pile at a time, right? I'm checking for every possibility, right? From one, if allies has taken one, right? This is for bob, right? This is for bob. If allies has taken one, so bob can take rest of the next one as well. Bob can reach to the second index, and bob can also take a two pile at a time, right? So bob can reach to third index, and both can also take 3 pile at a time. Both can reach to 4 index, right? So this is 0 is nothing but index, right? Inside of this, I'm just telling that where we are standing currently. So initially we were at 0 index, but after taking a one pile by a line, so we come to the first index where Bob has a turn, right? So this part is for Bob. For if allies take two piles at a time, so now Bob can take either one pile, either Bob can take two pile, right? So Bob can't take three piles because there is no more pile left. So if allies take all the three piles initially, so Bob is only left with one pile, right? So Bob can take only one pile. So this was for allies now. Now we are going to check for allies right now. The allies, what is the possibility for allies now, right? So let me little scroll up. Okay, and here now if Bob has taken also one, Bob is here, right? So we are at second index now. We can either take one, so we can reach to three. We can either take two, right? There's no more pile left. For three, if I am here, so I can take either four. We can reach to four index by taking one pile. I can't take any more pile, right? And here also. This is the simple recursion tree. I hope you understood this. What we are doing actually. For every place, we have a possibility to take at least one pile or two pile or three pile, right? And if we can't take this pile, so we are not moving on that direction. Here you can see we can't take two pile or three piles, so we are not taking that particular tree, right? So once this is done, now let's calculate the score, right? So initially the score was 0, right? But score was 0, right? So but allies come to this particular part f1. So by if allies take only one, we can say pile, so it's going to have the stone of first 0 index, that is nothing but 1. If allies come to the second index, that means here allies has taken 0 index and 1 index value, right? So 0 index and 1 index is nothing but 1 plus 2, that is 3. If allies come to third index, that means she has taken 0 index, 1 index and 2 index, which is nothing but result of 6, right? Now it's done for Bob. So for Bob is gonna take a turn from first index. So if Bob come to second index, so what we can say, Bob come to second index from one index, so Bob has taken the first index value, right? So first index is nothing but 2. If Bob come to third index from one index, so Bob has taken first index and second index value, that is nothing but 5. If Bob come to fourth index from first index, so Bob is going to take first, second and third index value, that is nothing but 3 to 5, 5, 7, 12, right? I have it making a sense, right? So what we are doing actually. So now Bob also gonna take here for two second turn. We can say Bob was initially at second index. Now Bob can take one index, means one pile at a time. So if we take one pile, so we can say Bob is coming to third index, and he's gonna add the value of second index, which is nothing but 3. If Bob take two pile at a time, so it's gonna add the value of second index and third index, that is nothing but 3 plus 7, 10. And at 4 index, now for this case Bob was at a second index, not second, third index. So Bob can only take one pile, right? There's only one pile left, that is 7, right? So it's going to take 7 stone here. Now again the Lice turn comes. So Lice was standing at the second index. Now Lice can move to the third index or fourth index, right? So like if let's take only one pile, so it's gonna is gonna move to the third index and it's gonna add the value of second index. That is nothing but we can say 3. Let's take both the, then it's gonna add the value 10. All right, and if in this case is standing at third index, and we can move to only one in pile, we can take only one pile and move to the fourth index, right? So we are gonna add the value of third index, which is nothing but 3, right? What is the third index value? This is 7, not 3, right? Now here also I'm gonna add 7. Now let's quickly we lose the one more thing with that is nothing but here we can also move 1 4, right? So this is going to be 10 for bow, right? Okay, so now what we're going to do, we're going to say here 7. Now guys, see guys, now it's the main part come. Now what we have to do actually, we have to find the alias minus bow, right? So here if you will focus on this particular part 6 and 7, right? If alias this particular case is going to also lose for alias, right? If alias make a choice of 6, if alias take all the 3 coins, then alias is going to lose, right? Because the next turn is going to give bow a 7 stone, right? So we can say 6 minus 7, right? We're going to get minus 1. And if we take here, if let's take 3 coin, 2 pile at a time and with the 3 stone, so the next turn for both, we are going to choose the maximum, right? So here the maximum is going to be nothing but what you can see 10, right? So here also you can say ally is going to lose, both going to win, right? We are getting minus 7. And here what we can say if I take only one coin, then there are many possibilities, but Bob is going to choose the which is the can say the maximum one, right? Bob is also going to play optimally, so Bob will not going to choose this 2 5 because they are going to end up with a less stone. So Bob is going to choose the 12, and which is also going to lose 2 allies, right? So Bob is going to win this time as well. 1 minus 12 is nothing but minus 11. And how we gonna come that this is gonna to choose 12 or 2 or 5? So this is basically recursion part. We are choosing we are just finding from we can say from bottom to top that which one gonna have to choose. So here we are having 7 for Bob. He's gonna make a choice, but here if you will see Lysa is gonna have 3, right? So if I tell you in this way, then you will not gonna understand. It's gonna take more time. You can understand, but it's gonna take more time. So let's move to the code and see how we can do this particular problem, right? So let's move to the code part and see how we can solve this problem. So guys, I am here with first of all Java, or let's take any of the let's take Java only first time, right? So here first of all what I'm going to do, I'm going to make a DP which is going to store the, we can see the value, right? We can do memorize, right? So I'm going to just do memorize. For that I'm going to make a DP, and DP size I'm going to go say new int, not 2D DP. I just need to make 1D DP, and the size I'm going to say nothing but the max size which could be possible, right? So the max size here you will see we have 5 into 10 raised to 4. So I'm going to say 5 2 to 4, right? 5 into 10 is to 4, so here I would write 2, right? So once this is done, what I'm going to do, I'm going to slice dp with minus 1 0.0 I less than 5 2. All right, and here I could say I plus plus, and here what I'm going to do, I'm going to say dp of I is going to be nothing but minus 1, or I can say 1 2 3 4. We can do like this, right? Why I'm doing this, because there could be minus possibilities, right? We can get also in minus somewhere on this dp, and we are going don't want to return there as well. So I'm going to slicing with minus 1 1 or we can say 10 raised to 5, right? So after done this part, we are going to call a function which is going to do our recursion part. So we can say solve. This is going to take a 0 index, start from 0, and we are going to pass this stone value there, stone value. Fine. So let me pass stone value here. Now we are going to this is going to return the difference between alias and Bob, right? So we can say difference, and if alias is this difference is greater, we have already checked if difference is greater than 0. So what we going to return, we're going to return that alias going to win, right? So we can simply say like this: if difference is greater than 0, then return alias. If it is not the case, then check difference is 0. If the difference is 0, then you are going to return tie. Else, let me write here question mark, and here let else you have to return both, right? So this was the case basically. Now let's make this particular function. So we're going to say public int sol, and in this function what we are going to do, we are going to say int index, right? And here we are going to take this particular stone value, right? Stone value. Once this is done, we are going to say if index is greater than stone value dot length, let me write stone value dot length. Then what we are going to do, actually we are going to say not greater, equal to as well, right? So if it is greater than or equal to, that means we come out the we come out of bound, right? So we're going to return directly 0. And if it is not the case, then what we are going to do, we are going to define first of all two variable, or we can check it first of all if that particular dp of idx is not equal to minus 1 and 450, right? So we can simply return dp of idx. Once this is done, we are going to define two variable into result, which is going to be the maximum result that time, and which is initially not 0, it is also going to be minus 10 raised to 5. So we can say 2, 4 and 5. And int, what we are going to say, we are going to say let's say we can say total, right? So initially we can say total as well. Now what we're going to do, we're going to traverse over this. So we're going to say 4 int I is equal to 0, I less than 3. We can take at least 1, 2 or 3 pile at a time, right? So we can say there are 3 possibilities for every index. So we're going to take first also, we can take second 2 pile at a time as well. We're going to take 3 pile at a time, right? So but we're going to take only when these are not out of bound, right? So we have to check one more condition. If I plus idx is not out of bound, right? So if it is we can say less than stone value, so then we can take it, right? I hope it makes sense, right? So we can say if less than stone value dot length, then you can take it. So let's take this particular value and find our result. So result is going to be nothing but max dot max, and here we can say result comma total minus sol index. We are going to pass this particular I plus idx plus 1, and we are going to say stone value. I know you are not getting this particular function, but let me just make this particular function first, then I'll re-summarize this particular thing, right? So once this is done, we are going to return our result. Before that, I have to store in dp, so I can say dp of idx is going to be nothing but result. Now guys, what actually I have done here, the first thing is nothing but we are checking out of bound condition, right? If it is out of bound, means in recursion call, if next time if you will focus here in my node, then if it here we come out of bound, right, f4, we can't take f5, right? So we are simply returning here the next point is nothing but gonna be nothing but we can say 0, right? So, all right, and the second condition, if you will see over here, if dp of idx is equal to this particular part, that means which we have already defined. If it is not equal to that particular part, that means this particular recursion, or we can say this particular recursion has already been traversed, right? If you can see, if we are coming the same condition in somewhere else as well, so we're going to say return that particular part what you are getting in that particular result, right? So we don't want to we can say traverse on that particular tree again if we have already traversed one time in the earlier part, right? So okay, after that we are doing, we are just checking a total and result variable. Now, what is this result or total variable? See, guys, on every time we have three possibilities, right? From 0, we can go to 1, 2, and 3, right? So, what we are saying on 0, if you're going, your total is going to be 1. If you going to 3, we can set second index, you're going to be total with 3. If you're going to the third index, your total is going to be 6, right? So, I'm just keep adding in total, and I haven't done, so that's cool. I have to add it again. Total plus equal to stone value of idx, right? Once this is done, I'm just saying that fine, if you have taken this one, right, if you have taken only one spice, then for next you have to calculate again. The same scenario is going to be nothing but act like f of 0 only, right? But the difference is only this, like here is we have f1, but this is actually the same thing we are doing. We are moving again to the three part, right? So this is the recursion which we can say again it's gonna act like this thing. It's gonna traverse we can say for three times, next for next we can say next number of index. So just to make you clear that initially we were at f of 0, right? We can move to all three direction. We can move to f1, f2, f3, right? But if I took f1, then for after that we can also from f1 both can also move to f2, f3, and f4, right? So both also have a three choice, right? So it's the same thing I'm doing. If I have to this particular index, right? Then I'm saying that okay, you have to this particular index. This is total. So now for both also you have to call the same function which can also choose the three pile at a time and with the same particular optimal case, right? So when this is done, we are going to return our result. So let's try to run this code and see whether it's working fine or no. So let's see this particular thing. And I got an error because which is semicolon error, fine. And I have to write a semicolon here as well, fine. Now let's see whether it's working fine or not. Okay, let's see whether do we have any more error. Yeah, one more error is there. That is nothing but okay, it is not a statement. Do we need to use a bracket here? I don't know what is this. Alright, so I think I have to use a bracket here, right? Here as well. If it is the case, then you have to run this particular part. So now let's run this code, see if it is working fine or not. Otherwise, we will use a condition, don't worry. But yeah, actually it's working, right? It's not a condition, so let's move to this particular thing. We can say if different is greater than 0, then we have to return what? We have to return alias, right? So let's say we are returning alias. Alright, and if it is we can say not 0, if it is less than 0, so what we are going to do, we can say if else if, so let me write a semicolon, if else if, right, if it difference is less than 0, so who is the winner? Bob, right? Return Bob. But if it is also not the case, so we can say return type, right? So once this is done, let me comment this line. Let's run this code, right? I hope now guys it will not give an error, but yeah, it give a wrong output, which is nothing but we have done mistake in somewhere. So let's check it out. What is the mistake, right? So this is the thing which we have done, and we are checking with this TP fine. And if it is not the case, so we are going to return true if idx is this. All right, so we are not adding an index, right? We have to add index plus I, right? Now we have to add that particular stone value, not that same index value again and again. Now it will definitely going to give a right answer. You can see all the test case passed. So let's try to submit this code. So by this we have successfully solved with the Java, and you can see, right, it got submitted. Now what we are going to do, we are going to move to the Python, and let's see what we can do with the Python. So for Python it's going to be really easy, and I'm going to do really little fast here. So I can say dp, which initially going to be array. After that I'm going to define solve function, which is going to be have nothing but index and not anything else, just only index. So we can say right index. After that I'm going to say if index is greater than or equal to what we can say length of this particular stone, right? Length of stone value. Let me write a stone, and here what we can do, we can say return 0, right? After that, once this is done, what we can say, we can say for I in range of 3, right? And before that I have to check one thing, that is nothing but we have to check if that index is already been traversed. If index, or we can say like this, if index in our dp, then return dp of we can say index, right? If it is also not the case, then you have to make two variable result and comma total. Result is going to be nothing but a negative value, so we can say result is going to be nothing but minus 140, right? And total is going to be nothing but we can say, what we could say for total, we can say 0 only, right? Once this is done, what we going to, we can say first of all check if I plus idx is less than, if it is less than our stone value dot length, then it's fine, right? Stone value dot length, right? If it is fine, then we are going to take this particular total plus equal to, we can say stone value of I plus idx, and we have to call this thing for the, we can say both part as well. So we're going to say result is going to be nothing but maximum of result, and solve this particular function for bob as well. So for that index is going to be nothing but I plus idx plus 1, and we're not going to pass anything else, right? Once this is done, we are going to return our result, right? And before that I have to insert this thing in our dp. So dp of idx is going to be nothing but this particular result. Once this is done, we are going to call this function for 0 part, and we are going to check it. First of all, let me make this particular thing in difference variable. Now we are going to check it. If difference is here, I guess we can do, right? If difference is greater than 0, if difference is greater than 0, that means what we could say, if it is greater than 0, then bob has, alias has been, right? So we can say alias. So let's make this, I don't know why it's not working here as well. If difference is greater than 0, so what we can do, we can say okay, right, let me do like this as well. Difference is greater than 0, same. It's not working, question mark, I don't know why. All right, so let's do now this again. I got frustrated this time. Difference is greater than 0, so what are we going to return? We're going to return nothing but alias, right? And if else, if elif, let it take elif, right? So what we can say, if difference is less than 0, so who will gonna win? Return O. And if it's not the case, then return, we can say tie, right? Now let's run this code and see whether it's working fine or not. And we have to run this. Let's see. You can say third case pass, but not rest of the case, so it's returning a 0 for bow as well, right? So do we have done something mistake here as well? So I am adding this particular part. If index is fine, and this total is as well good. If index is greater than length of stone value, fine, it is going to return a 0 part. But if index in dp, so we're going to return dp part. And result, okay, so I have defined result fine, it is fine, result is going to be this one, and total is going to be 0. If index I is fine, I think I have done right. So just we are going to call this for 0. Okay, and if we have done this in dp, right, if this is in dp, so we are going to return dp of itex, fine. And after that, for dp of itex, we're going to pass I plus itex plus 1, right? It makes sense, right? So when this is done, we are going to return our result. All right, so I think it's working fine. Why it's giving a tie, right? So let's check next one as well. So all are giving a tie. Why it is the case? If difference is greater than 0, right? So let's check out the difference first of all. So print with the difference. Do we have something wrong here in this case? So here I'm getting a 0 every day. Alright, so guys, the thing is nothing but this is thing we got 8. Alright, so we are not subtracting total here. So that's why it's giving again 0, right? For Bob, it's not gonna be like we have to subtract now. So this you can see case 1, case 2, and case 3 all are passed. So let's try to submit this code. Now let's move to the next programming language that is nothing but C++, right? You can see it got submitted. So now let's move to the next programming language that is nothing but, okay, let me do this, C++, right? So here again quickly we are going to do what? We're going to make our DP array first of all. So we are going to say int DP is equal to mean nothing but let's define a size here only, which is nothing but 5 4 2, right? Now once this is DP done, we are going to say for int I is equal to 0, I less than 5 2. I can use m set function, but it's not fine. I'm just going to do with the loop only, right? I plus plus. Here I can say dp of I is going to be nothing but minus 40. Alright, so even you can get 50 as well. Once this done, we are going to call a for index. So index, if difference is going to be nothing but solve, I'm going to start from 0 index. I'm going to pass this stone value there. Once this is done, I'm going to check if difference is greater than 0. So you can return nothing but we can say alias, and else if difference is less than 0, then you can return so. Otherwise you have to return tie, right? So else you can return tie. All right, so now let's make this function only. We are just left with the function. So I'm going to say int sol is going to take an index, it's going to take a vector int, and we're going to say stone value, right? Once this is done, we are going to say if index is greater than or equal to length of, not length, here we have to use a stone value dot size. So we're going to simply return our 0, right? If it is not the case, let's check it. If dp of idx is not equal to this, if it is not equal to this minus 4 not 50, then we have to return dp of idx. Once also this is not condition true, right? So we are going to come here, we are going to say int result is nothing but 0 not 0 minus 10 or 5, whatever you want to make here you can make it. Int dp, no dp here, target total we can say, right? Total is the best, total is going to be 0. Now we are going to have three possibility here for int I 0, I less than 3, I plus plus, and here what we can say, we can say dp of or we can say first of all check the condition if it is not out of 1, right? So if I plus idx is still less than, if it is less than stone value dot size, so what we can do, we can say cool, we can take this particular, we can say index as well, right? So we can take this file, so take this file total plus equal to uh, stone value of idx. Once you have taken this file, you can not idx plus 1, right? Idx plus I, right? So once you have taken this file, what you can, so you can say check for the bow, right? So you can say result is going to be nothing but maximum of result comma total minus stone, not stone, we can say this sol function sol, and here we have to pass idx. Which one idx? Idx plus I plus 1, because idx plus I till we have taken the coin, right? The next index is going to be nothing but plus 1. So when this is done, we are going to return our result, right? So let's return a result. Before that I have to store in dp, so I can say dp of idx is going to be nothing but this one. Now let's run this code and see whether we are getting any error or not. So I don't think we should get, right? And here I want to try this particular thing as well. So it's not okay, we haven't passed the stone value array, right? So it's not a Python. Okay, now first of all let's see, you can see all the test case passed, right? So now I want to check that condition here as well in C++, whether it's working fine or not. So difference is greater than 0, right? If it is greater than 0, then you have to return what? You have to return alias, else no, alive, you have to return alias, else if it is not the case, then you have to check if difference is equal to 0, right? If it is not the case, then you have to check what is happened. I don't know, we have done the submission one, right? Okay, and if difference is equal to 0, then what you have to do, you have to return the bob, right? Or die. So we can say if difference is equal to 0, then you have to return die, else what you can return, you can return bob. Fine, now let's run this code and see whether it's working fine or not, and let me remove this one as well, right? Okay, let's run this now. No, it's also not working here. I don't know why it's saying something, it's wrong here as well, right? Return is mistake. return, right? You can see it's working in the C++, right? So we can use this particular statement instead of this particular if else. Right, now let's try to submit this code, and I hope it will also get submitted, right? And here we go, guys, right? So we have successfully solved the problem in C++, Java, and Python. We have seen the logic part. We have understood the problem. If you still have any kind of doubt in any of the part, you can write in the comment section. I'm always there to help you. And if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.